Hello students, welcome back to my YouTube channel. This will be the last class for trigonometry. We have done many problems based on LHS and RHS. This will be the continuity of the last class. Here I'll be taking up some of the condition based problems. I've got one problem here. You have to find A and B, where A and B are acute angles. Sine of A plus 2B equals root 3 by 2 and cos of A plus 4B equal to 0, where A is greater than B. Now two conditions are given. Under those conditions you have to find A and B values. I'll take up the first condition that is given here. Sine of A plus 2B equals root 3 by 2. Now if you have to equate LHS and RHS, both have to be under the same function. If you take up standard angles, root 3 by 2 in terms of sine, it is going to be sine 60 degrees. So what I do here, I write it as sine of A plus 2B equal to root 3 by 2 can be written as sine 60 degrees. Now you can see both sides it has got the same function, that is sine function. Equating those two functions, we take up the value as A plus 2B is equal to 60 degrees. We'll keep this as first equation. Similarly, we'll take the second condition what is given. It says cos of A plus 4B equal to 0. Again, you have to bring it under same function here for cos. Cos of A plus 4B equal to 0 is going to be cos of 90 degrees. So we equate LHS and RHS with cos value. So A plus 4B is going to be equal to 90 degrees. So this will be the second equation. Now to solve this, we go back to the chapter of linear equations in two variable, because you have got two variables A and B to be solved. So we'll say from 1 and 2. So I take up first equation, A plus 2B equal to 60 degrees, and the second one, A plus 4B is equal to 90 degrees. Now here, we are going to do up with elimination method. We have got the same values here, A and A. So change of sign in elimination method, this is minus. So this also I change it as minus, and this will be changed as minus because positive value. Plus A and minus A gets cancelled. 2 minus 4B is going to be minus 2B, which is equal to 60 minus 90. 60 minus 90 is going to be minus 30 degrees. So minus and minus gets eliminated. So left out is 2B is equal to 30 degrees. B is equal to 30 divided by 2. So B is going to be equal to 15 degrees. Now next you have to find out A value. Either consider first equation or second equation. I'll take up first equation. A plus 2B is equal to 60 degrees. So A plus 2 into B is going to be 15 is equal to 60 degrees. So A plus 15 2s are is 30 is equal to 60. So A is equal to, shift that, 60 minus 30. A value is going to be equal to 30 degrees. Therefore, acute angle A is equal to 30 degrees and acute angle B is going to be equal to 15 degrees. It is going to be. This is a consideration which is taken up. We will look into the next problem. Okay, coming to second problems. Second problem is again, you have got certain condition here. It says x is equal to A sin theta and y is equal to b tan theta. Based on this condition, you have to prove that a square by x square minus b square by y square equal to 1. We'll take up the condition and then we'll go into the problem. We'll look into what is to be done here. So we'll take up the first condition what is given. It says first condition, x is equal to a sin theta. So x is equal to a sin theta is taken up. Now here its product it is, so this can be cross multiplied. That means I can write it as x by a is equal to sin theta. Now if I look into the condition it says a square by x square or a by x, and here it is b by y. But I've got a value here as x by a. So to convert it as a by x, I'll have to reciprocal it. So if I reciprocal LHS, RHS should also be reciprocal. So I reciprocal this, it becomes a by x. This gets reciprocal, so it is going to be 1 by sine theta. This we'll call it as 1. Now we take up the second condition. Second condition, it says y is equal to b tan theta. So in similar ways what you did here, cross multiply y by b is equal to tan theta. For my problem I require it as b by y. So I'll reciprocal this. So when I reciprocal, this is going to be b by y is equal to 1 by tan theta. So we'll call this as equation 2. Now I've taken up the condition, I've brought it to the requirement of the LHS part. I'll take up LHS now. LHS says a square by x square minus b square by y square. I have to prove it as equal to 1. Now since numerator and denominator have got both the squares, so I'll whole square it. So I write it as a by x whole square minus b by y whole square. So from 1 and 2, I've got a by x value as equal to 1 by sine theta. So in place of x, I write it as 1 by sine theta whole square minus b by y, I've got a value as 1 by tan theta. So I write it as 1 by tan theta and that square along with that. So here I'll write from 1 and 2, the substitution. Now square it, so this is going to be 1 by sine square theta minus 1 by, this is going to be tan square theta. Now tan square theta can be written as sine square by cos square. So what I do here, I keep this as 1 by sine square theta, or directly you can convert it, or 1 by sine square can be written as equal to cosecant square theta minus 1 by tan square according to reciprocal ratios can be written as cot square theta. Now we go back to the identity. Identity, what it says is 1 plus cot square theta is equal to cosecant square theta. Now if I shift this cot square that side, that means it is going to be cosecant square theta minus cot square theta, value is going to be equal to 1. Now this is according to this identity or the manipulation which is done. So cosecant square theta minus cot square theta value is going to be equal to 1. So this is going to be RHS. Therefore LHS is going to be equal to RHS. So these are certain problems where certain conditions will be given. Take up the condition, you are going to use it in the problem in certain ways according to the requirement, and then we get into LHS equal to RHS. We have used identity 1 plus cot square theta is equal to cosecant square theta. When you shift it, cosecant minus cot square is going to be equal to 1 let us. Okay, we'll look into the next problem, third one. Okay, the next one, the third problem. Again, it is a condition based problem. Two conditions are there. It says if tan theta plus sine theta equals m and tan theta minus sine theta is equal to n, then you have to show that m square minus n square is equal to 4 root mn. So I'll take up the LHS part because I've got direct values for m and n. So if I take up LHS, that is m square minus n square. So substituting the values, here it is going to be tan theta plus sine theta whole square minus, this is again tan theta minus sine theta whole square. Now two of the possibilities, this can be done in two ways. Either you apply a square minus b square, or you can apply a plus b whole square and a minus b whole square formula for this. Now if I apply a plus b whole square, then this is going to be tan square theta plus sine square theta plus 2ab, 2 tan theta into sine theta. So I applied a plus b whole square, a square plus b square plus 2ab. Then sign is minus. Whenever minus sign is there, maintain a bracket. Again, it is tan minus sine whole square. So a minus b whole square, tan square theta plus sine square theta minus 2ab, 2 tan theta into sine theta. Now the next step is opening the bracket. So when I open the bracket here, it is tan square theta plus sine square theta plus 2 tan theta into sine theta minus, when you open this, tan square theta, minus into plus is minus sine square theta, minus into minus is plus 2 tan theta into sine theta. Now in this cancellation, positive and negative, plus tan square minus tan square plus sine square and minus sine square. Now here I have got same terms, 2 tan theta into sine theta plus 2 tan theta into sine theta. Like terms both of them. So you can add it, 2 plus 2 is going to be 4 tan theta into sine theta. So we have taken up LHS and arrived at certain value and we call it as 1. Now RHS, you have to prove it as 4 root mn. I will take up RHS, 4 root of m into n. So I keep this 4 as it is, root of m value. M value is tan theta plus sine theta into n value is tan theta minus sine theta. Remember, you have to bring it to the same value. You have to eliminate the root also. So 4 root of a plus b into a minus b. A plus b into a minus b is going to be a square minus b square. Now to get out of the root, you have to get a whole square there. So what I do further is, I convert this tan square theta, writing it as sine square theta divided by cos square theta minus sine square theta. So further, we'll keep that 4 as it is. Root of, we have got a LCM there. LCM is cos square theta. So we'll write LCM as cos square theta, which is inside the root. So when I multiply cos square, it gets cancelled, only sine square here. Minus, so cos square had to be multiplied here, so it is going to be cos square theta into sine square theta. Continuing the 4 root of, numerator you have got a common, that is going to be sine square theta. Bracket you are going to be left out. If I take out sine square theta common, here 1 is left, minus cos square theta divided by cos square theta here. Now further, 4 root of, these two I will combine together, that means I can write it as sine square theta divided by cos square theta into, according to the first identity we write it as sine square theta plus cos square theta, value is going to be equal to 1. Now if I shift this out, sine square theta is going to be equal to 1 minus cos square theta. So 1 minus cos square theta is equal to sine square theta, it is going to be. Further, I want that root sign to be eliminated. So what I do, sine square theta by cos square theta is going to be tan square theta into sine square theta. Further, both of them have got square. So 4 root of tan theta into sine theta whole square it is. So now the square and square root will get cancelled. So answer is 4 tan theta into sine theta. This we'll call it as equation 2. Therefore, from 1 and 2, so 1 is going to be 4 tan theta into sine theta, 2 is also 4 tan theta into sine theta. From 1 and 2, LHS is equal to RHS. An important problem, we have used identity and we have used algebraical identities also, a plus b into a minus b. This you can use as a square minus b square also. We'll come to this same part of LHS it is going to be. Okay, stop it. So we have come to the end of trigonometry chapter. Still many more problems to be looked into it. Whenever I do question papers, or when you do the revision of the complete syllabus, I'll take up papers and the syllabus part, whichever important questions are there. When I do it up, I look into trigonometry, those extra questions also. Each and every chapter will be looked into it, and we'll do papers also. So next class we'll look into some other chapters, or we might start with the question papers and start the preparation for the final exams. Thank you. Subscribe and share my channel.